Hello, Zerman. Guten Morgen. So my name is Dario. Dario, forget the surname, is always getting butchered. I'm from Italy, as you can guess, Tranchitella. And today I would like to talk about my opinionated stack to create a Kubernetes platform. So we are in Switzerland. I don't know if you're getting triggered, but it's pretty popular in Italy. Every time we talk about Switzerland, we are talking about the Swiss Army knife. And today, essentially, I want to show you how can you use this analogy to create a platform. And of course, keep in mind that I'm from Italy, so there is a lot of humor. I try to calm me down, but this is the average Kubernetes Swiss Army knife, and this is the average Italian Army knife. Of course, I really love wine, so I got some friends from Switzerland, and I said, I'll bring you a lot of wine, and that's the reason why I selected the corkscrew. So, humors aside, so this is the agenda. And I don't want to do a spoiler here, but this is the whole stack we are going to get through across all the presentation. So let's talk about the elephant in the room. So the problem we are trying to solve. And essentially, it's about multi-tenancy. When I started working on the open source, multi-tenancy was something very interesting for me, mostly because, essentially with the multi-tenancy, you have one cluster, which is absolutely great. So essentially, you got your own path. And for the reliability, unfortunately, is very bad, because what's going to happen if the cluster goes down? Essentially, well, it's very problematic. So in the end, you're ending up with multiple clusters. So you can have several islands, so you can, distribute the risk across the clusters. But it's very hard because essentially you have to tame essentially a fleet, and you can't scale yourself like 2 replicas, 3 replicas, and so on and so forth. And sometimes all the discussions I had in the past was, doesn't matter the CRDs, but you can try to use a single cluster for the multi-tenancy and rely on the namespaces. And my opinion is that sometimes multi-tenancy is required because, sometimes sharing some parts of the cluster is not very convenient. It really depends also on your concept of privacy. But essentially, this is the slide I really loved. Keep in mind that this is not my content. So essentially, I discovered this slide and this concept from one of the adopters of Project Capsule. It has been my first open source project, which summarizes essentially the pitfalls of multi-tenancy in Kubernetes, because one cluster is great for the operations, but it's a nightmare in terms of reliability. But if we have multiple Kubernetes clusters, we are safe, but the operations, of course, are getting troubled. So how can we overcome this situation? Essentially, we need to dissect the problem and try to understand what is multi-tenancy in a Kubernetes cluster. So essentially, we are not talking about a single or a dozen, but we're talking about a dynamic approach of multiple clusters. So we are in the scale of hundreds or even thousands. And we can't wait for tickets, So just try to imagine that you want to get something from AWS, from Azure, or your cloud provider. You're not opening a ticket. You have a portal. And from that portal, you got everything baked in and already prepared to get consumed. And this creates some issues also because as developers, as site reliability engineers, we need to create something that matches the expectations of the security, but likewise also the same expectations for the UX. So if you remember, I said how we talk about the concept that having multiple clusters is very problematic for the operations. I've been a site reliability engineer, so I know what I'm talking about. PagerDuty is not my friend. I'm sorry for PagerDuty, the company. But essentially, I like to have a single cluster to manage the entire platform. It's like Lord of the Rings. We are in a cinema, so it's the perfect analogy. One ring to rule them all. So one cluster to rule them all. And this is the architecture. So I would like to have a Kubernetes cluster where I'm defining all the clusters, and then the worker nodes from different VPCs, from different networks, they're just attaching to the cluster definition, and I can control in downstream modes, so from the upper to the lower level. How can I do that? It's very complicated, to be honest. So essentially, we are going to talk about technology, and my background is that now I'm doing software engineering. I used to be a site reliability engineer, and prior site reliability engineer, I was doing software engineering. So essentially, it's a melting pot of knowledge and design patterns. So essentially, we need to try to implement the composition. So we need to select tools that are not stepping on each other's toes. And essentially, Kubernetes is the perfect choice here, mostly because we are going to see that we are going to focus on the CRDs. So CRDs is the acronym of Custom Resource Definitions. And also about the tech stack, it must be very, very opinionated. So sometimes I talk with fellows, they're saying, but maybe selecting FlexCD or Argo CD could be too much cumbersome. You need to be open. And that's true, but rather here we need to defend our choices. So essentially, every time when we are making a choice, we are creating a lock-in. And that's absolutely fine. So it's the same thing I always try to explain to my daughters. Of course, they're not listening to me. But every time you do a choice, you must be aware of what you're doing. And likewise, also here with Kubernetes. So let's talk about the mental model. So essentially, we need to create a sort of combination of tools, as I said before, and each tool must be swappable. So it's a sort of interface connecting to the spine. And here you can see that we have the lifecycle. So what is the lifecycle? Essentially, I want to create the provision clusters, manage the quotas, and so on and so forth. And then I'm biased, and I'll tell you later why. We need to take care of the control planes. So essentially, in a Kubernetes cluster, worker nodes are cattle, so they can, I'm very sorry to say that, they can be killed. We are in a Linux world, the kill command is not so very gentle. So we can kill the worker nodes, but the control plane is like a pet. And taking care of pets is very time consuming. And also in terms of resources, it takes a lot. And we need to take also about the multi-tenancy. So the multi-tenancy is something that you want to offer to your own customers. It's like the bathroom picture we saw together. So essentially, you want to get your own apartment with your own services, with the illusion that everything is designed just for you. But for the operations, of course, well, it's a different story because you are combining all the costs, all the stack, and so on and so forth. But a Kubernetes cluster is not just a matter of infrastructure and tenancy. Of course, you need to install something on top of that. Just thinking about the CNI for the network, for the storage, we have the CSI, or maybe several other add-ons like the monitoring, the observability, and so on and so forth. And last but not least, how can we create the glue that connects all the dots together and create the real spine? It's about the GitOps approach, which is mainstream, I will say. So let's start with the large blade, and the large blade is Cluster API. Just a quick question, raise your hand. Who knows what is Cluster API? Wow, this is the Cluster API room. That's great. So I'll try to be very brief. But essentially, Cluster API, I'm from Italy. I use a lot of Latinism. It's the de facto standard for multi-cluster management because it reuses the same concepts of Kubernetes. So you have the CRDs where you can define the cluster definition, and then you have some interfaces like the machines that are connecting to the cluster. But of course, we all know that the infrastructure is very different because vSphere is different compared to OpenStack, from KubeVirt, from Proxmox, and so on and so forth. Every implementation has its own quirks. With Cluster API, essentially, you have the abstraction, and then you can plug your own interface. And what I really love is that, according to the design I was thinking, Cluster API perfectly matches the concept of having one cluster, and in this cluster, I'm managing multiple clusters, child clusters, downstream clusters, call whatever you need. And everything is a Kubernetes object. I'm a huge fan of the CRD's approach, even though it's the perfect recipe to get the API server, well, not the API server, but the etcd going to destroy itself due to the size because it's not storing data in protobuf, but rather in JSON, but it's a different story. We can talk about that later after the talk. I'm a nerd about the internals of Kubernetes. So, Cluster API is great. Well, yes, but actually no. So, you see here that if I want to create a cluster, I got several components involved. So I got the Cluster API, cluster, and then the machine deployment with the machine set, with the machine, and I'm missing, well, there is also there the bootstrap configuration. So every box you see here, it's a custom resource instance. So I'm going to get my spec, and unfortunately, there is not enough space in the screen. This is just a small glimpse. And you can imagine how much boilerplate you need to create a Kubernetes cluster using Cluster API. It's not faulty. It's by design, of course, because creating a Kubernetes cluster is not, just assembling something together. It's always about engineering. So Cluster API has a solution. And this solution that I really loved is cluster class. With cluster class, essentially, you're doing a sort of, I will call that as a sort of templating of all the objects. It's a sort of orchestrator to create all the manifests together. And the feature I really love is about variables. You can see here, it's bold. With the variables, essentially, you can create a sort of customization for each cluster. And it creates also a very nice UI. And I'm going to show you also the manifest, but there are several benefits from Cluster API. It's debatable, of course, so strong opinions weakly held also here with Cluster API. But the result here is absolutely mesmerizing for me. So it's very easy to understand. These are mostly real manifests we are using at my own company. But you see here that we have the bootstrap config. So it's a variable I'm defining. And that variable, it has a value. It could be a string, an integer, a struct, whatever you want. So essentially what I'm going to do is that I want this cluster. This is my domain. This is my interface. And with this interface, I can connect to multiple infrastructure providers. But how can I use that variable? That variable essentially is defined as an OpenAPI free schema. So I'm an API guy. I was writing API specifications for a long time. And essentially, it's what a developer is expecting. So it's pretty straightforward to understand. It requires some, I'm not lying, it requires some efforts in trying to understand, but the outcome is absolutely mesmerizing. And since I said I'm an API guy, how can I use the variables? Well, using the JSON patch RFC should be 6902. Maybe I'm wrong, but essentially it's very elegant because you see there, I got the JSON patch and I'm asking, please put my default control plane virtual IP with this value on the spec template, spec server's address. So I'm traversing the structure of my object, which is the selector, the Kairos config template. So essentially, I'm getting something very elegant to patch all my manifests. So the good thing is that if you're used to customize, essentially this is pretty similar to customize, and it's not like Helm where you got an issue because you missed a white space and it's entirely broken. So it's not just a matter of cluster class, but this is one of the components I strongly suggest, but it's also about the runtime SDK. So runtime SDK, it's essentially webhooks. Who loves webhooks in Kubernetes, All the issues we got in a Kubernetes cluster is all about webhooks. But I'm just joking. But it's very powerful because with the runtime SDK, essentially, you can create your own domain logic for the clusters. So let's imagine I got a cluster, and this cluster, it needs some permissions on the router to get external traffic, or maybe to register itself into the building system. How can you do that? Of course, if I'm a human, I'm going to create, the building entry in the system. Then I create the cluster, I connect the cluster. So all human interactions. But here, I can use the hooks. And I got plenty of hooks, like the before cluster creation, after the control plane, workers. So I can connect my own logic, which is not just the infrastructure, it's something else, is my domain logic. So I'm creating a product. So let's talk about the corkscrew. So it's about wine. And wine is perfect, is the best beverage in the world. And this is why I selected Kamaji. I'm not just joking, At the conferences, I always talk that I got two twins in high availability, they are almost height. So I got, in reality, 4 children. So I got Iris, Luna, and then I have Project Capsule that now is very great project because it's in the CNCF. And then there is Kamaji, the latter one. And Kamaji, what it's doing essentially? It's doing what I was dreaming when I was a site reliability engineer. So no control planes, essentially. So the control planes are self-maintained. And how can we do that? Of course, it's debatable, but it's going to be another the de facto standard, they're running as pods. And running as pods, it means that we don't have virtual machines, or rather, the control plane running as pods, they're treated as a Kubernetes object, as a Kubernetes resource. And it provides a lot of benefits, essentially. The huge benefit is that we are offloading Kubernetes itself to manage the control planes logics, like the creation of the certificates or the high availability of the deployment and everything you're expecting to take care of a Kubernetes cluster, like rotation of the certificates. Who has maybe an alert saying your certificates are going to be expiring in 3 days, and you have the ticket and you have to do that. Well, essentially, Kamaji is doing that for you. So it's your companion in terms of site reliability engineering. And why I'm using that, of course, because I'm biased, but essentially the benefit is that everything is running as a pod in this management cluster, and it matches my design of having the huge Kubernetes cluster maintaining my own platform, because I have the API server, the control manager, and the scheduler running inside of the same network space. We can talk about that later. It's one of the objections I'm always getting, and I'm used to that. But the main problem is that if we are talking about multi-tenancy, if we have the worker nodes in their own VPC, so it's a subnet with no access to the management, because you don't want to grant access to the management network, how can we get the control plane interacting with the kubelets? Because remember that, of course, the kubelet must join the API server, but the API server, to fetch logs, perform exec, and so on and so forth, it must connect to the APIs with the kubelets of the worker nodes, but they don't have a public IP, or maybe they don't have a routable configuration. Well, essentially, there is connectivity. Connectivity, if you ever used Azure AKS, or if I recall correctly, also Google Kubernetes engine, but essentially it's a component, an upstream component that creates a reverse tunnel from the worker node. So the worker node initializes a connection with the control plane in gRPC, and gRPC is great because essentially it's a bidirectional. So the API server and the kubelet, they can use the same tunnel to perform all the actions, and it's very, very powerful. And after the corkscrew, we have the scissors and my third child, so Project Capsule. So what is Project Capsule? Essentially, it's a tool to create your own framework for multi-tenancy. It's not a product, it's a framework. So you have always to select the open source projects, not like products, which are essentially ticking all the boxes, but rather they are just a tool, a framework. And this framework, it allows you to create a slice of a Kubernetes cluster. And what is a slice? You can say, we already have the namespaces. So Dario, what you're talking about? But yeah, one namespace sometimes is not enough. You need to create multiple namespaces. Just thinking about the projects you can have on any cloud provider, you are separating the resources according to accounts. So the analogy here is that a namespace is going to be a project. So you can have one or more projects, and each project is containing all the definitions for the VPC, for the control plane, for the clusters, and everything else. But what I really love about Capsule, which unfortunately I'm not contributing anymore, except for leading the project, doing the PR, is that it's a framework, and it allows you essentially to define, again, a CRD for the tenant. And you can see here that we got the resource quota. And the resource quota, it's a namespace scoped object. So it means that you can assign a quota just to a single namespace. But if I have multiple namespaces, I want to have a dynamic quota, because my quota is not just about the project itself, but rather it's a quota for my own tenant. And this is done automatically by Capsule. It allows you to have a dynamic provisioning, and there is also a nice feature from one of the latest releases where you have also the resource quota claim. And kudos to Oliver, which is doing a great job on Project Capture, but also the whole maintainers behind the project. And since everything is a Kubernetes object, you can do a lot of stuff. You can use the impersonation. So with the capture proxy, you can get also the list of just your own namespaces. So it's very convenient, because if you're using the API server of the management cluster we discussed before as the single entry point to manage all the resources, with capture proxy, you get a list of just your own resources, even cluster scoped resources. Sometimes we're delivering CVEs, but it's open source. I'm really sorry for that. But we just recently released some CVEs. But it's open source, guys. Come on. So let's talk about the I don't know how to say that in English word. I was using Google Translate. It should be all, the all, also known as the Dreamer, essentially. So what's the Dreamer? Another project I'm fostering a lot. It's mostly from Italy, from Gianluca Mardente. He came back in Italy after a lot of years in the Bay Area. And Project Sveltos is the tool. So I don't want to push so much on the open source, but there are so many disruptive open source projects, and Project Sveltos is one of those. And what I really love about Project Sveltos is that it matches my expectations in fleet management. Let's talk about the story. I am a site reliability engineer. I have hundreds of clusters. And how can I upgrade the CNI? Doing the CrowdStrike, of course. Yeah, I was just joking, but updating all the CNIs across all the clusters. Sveltos is doing that. Sveltos, it provides a set of CRDs where essentially you can define the classification of the clusters. So I want to upgrade just these clusters because they have this version, minus version, or patch version matching my criteria. And then I can create some connections across the add-ons, because we all know that sometimes before installing Cert Manager, I need the CNI ready, and I need to prioritize the CNI installation. Essentially, everything is done by Sveltos. It's a lot of objects deployed, but essentially it's like Kubernetes. You have several controllers, and these controllers, they're doing do just one thing, and they're doing very well, essentially. So the last thing that I was forgetting is that you can select the clusters using labels. You are not using names. And this is very important because it matches the selection goals, set targets by Kubernetes itself. We are not selecting objects by name, but rather by labels, the pods by labels with the service, and so on and so forth. And of course, we can use a single object to match multiple clusters, and we can define values per clusters. So this is a huge win, because in the end, we are ending up with if else, if else, if else. It's declarative. But a YAML worth thousands of words, or vice versa, I don't know. But you see, this is the manifest. So I can install Cilium on all the clusters matching the label CNI equals Cilium, and I can install the Helm chart with these values, and essentially, there is nothing to do. I mean, it's pretty easy to understand, right? To debug, maybe it's a bit complicated, but it's part of the game. So, after Project Sveltos, we are going to talk quickly also about the features. You can customize a lot of stuff. It has also the approach to get the drift detection is very, very powerful. And essentially, there is also the one-time sync, which is very powerful because sometimes you don't have idempotent operations. So you need to sync just a sort of ignition of the cluster, just injecting some default values. And furthermore, it's event-driven, which is very powerful because everything in Kubernetes is an event, is something that you need to push. And essentially, with Project Sveltos, we can connect and we can do a lot of our stuff. And of course, I will say, why don't you use Fluxity or Argo application sets? I'm not a huge fan of Argo because maybe I'm too much biased, but the main problem is that you don't have the ability to extract values from the management cluster, which is your own source of truth. And Fluxity, instead, it doesn't have a fleet management. You can do that. You can ban the tool, but every time you're banning the tool, essentially, you're breaking something. So everything must be a sort of orchestra. All the instruments, they need to play their own role at their own pace. Well, directed by a director, of course, but they don't need to change the approach. So if I have, I don't know, an instrument, I'm not pretending to play like another instrument. And finally, let's talk about the later part. So essentially, we have Fluxity, which is reconciling all the objects, so the cluster classes, and it pulls all the information from Git. And we are using that essentially to create the connection, so install everything. It's our glue, essentially, or the spine, let's call it about that. And the result is that we have an assembled knife. So from Git, we are pushing. I have some doubts, honestly, about this approach. It's open for a chat, and essentially everything must be based on Git. It's mainstream, essentially, the GitOps approach. And the flow is that I'm committing, and Flux is pulling Capsule and Kamaji and Cluster API. They're provisioning the clusters, and Project Veltos is installing everything. So with a single Git commit, essentially, I removed a lot of toil from SREs. Also because if I have to do all these steps manually, essentially, it's like this one. If you release, it's one of the memes I loved so much. So I was doing memes before working for Classics. No, just joking. So maybe it was would have been better doing memes rather than working for Classics. But jokes apart, essentially, the composition is very important. Essentially, we have Kubernetes, which is going to be our spine, our management cluster. The API is the single source of truth. And we are reconciling from my GitOps everything into the cluster with the tenant definition, the clusters. And the reason of these approaches will be, why do you need to do that? Essentially, what I'm doing here in this architecture, there are some missing steps regarding also the OS management, how to provision the OS. But essentially, you saw all the projects, they're not stepping each other and they don't have a sort of interconnection. Of course, Cluster API is the huge umbrella because Kamaji is connecting with Cluster API as well. Also, Project Veltos is reading the definitions from Cluster API, but essentially it's a huge contract. The good thing is that it's not a one single purpose tool, one single purpose platform, but each controller has its own set of CRDs, and essentially it's managing that. And if something is getting broken, of course, you can use the Git, you can blame Git, of course, just joking, but you can roll back. You know what? You need to absolutely have provisioning time in no time. When I read this Reddit post, I was absolutely upset saying, oh my gosh, it's pretty impossible. I mean, 4 days to create a cluster, well, it seems that it's still doable. But if you want to know more, we are sponsoring also here as Classics, Zurich 2026. An amazing event. I'm really impressed also because I'm organizing Cloud Native Days Italy, and we got a booth. Let's talk about that later. And if you have any questions, if you want to get in touch with me, you got my name and my surname, and it was a pleasure. Thank you so much.